With transforming formulas, you are still working with solving an equation using inverse operations, but we're not actually solving to find what the value of a variable is. We're just rearranging the terms in a formula to solve for a specific variable. So for example, in the equation s equals 2 times pi times r times h, and we want to solve for h, this just simply means that we want to get h by itself. So in this equation, here's where h is. We want h by itself, and all of this is multiplied by h. So we can actually undo all of this in one step by dividing both sides by 2 pi r. Then each of these is equal to 1, because 2 divided by 2 is 1, pi divided by pi is 1, and r divided by r is 1, giving us h by itself. And then the other part of our formula is s divided by 2 pi r, and there's that formula transformed. Another example, if we want to solve for a, the first thing we have to do with this one is to apply our distributive property so that we can get our a term by itself. And the distributive property has us multiplying c times a and then c times b. So c times a, we can write it as ca plus c times b is cb, all set equal to d. And since we want a by itself, this is the term that has a in it. So we would want to do the inverse of adding cb, because we want to get that ca term by itself. So the inverse of adding cb would be to subtract cb on both sides. And again, we're just moving variables. We're not actually coming up with a number equal to c. So subtracting cb, this equals 0. It's like it cancels off. And we have ca is equal to d minus cb. And one last step, we want a by itself. So we are going to divide this side by c and divide this side by c. c divided by c is equal to 1. So we have a equal to d minus cb all over c. And another way of writing this, you can also think of this as dividing each term by c. So for example, we had ca equals d minus cb. If we divide every term by c, it's still the same thing. c divided by c is a. d divided by c, we'd write that as d over c. And then c divided by c is 1, so we'd have just minus b. Both of these two are equivalent. They equal the same thing. It's just this one showed dividing every single term by c. This one has the entire difference divided by c. And one last example. This one we need to solve for f. And you can ignore this part up here. It's for a different unit number, but it's the same thing. So in order to solve for f, again, this one we have to use our distributive property. So multiplying through that 5/9. So c equals 5/9 f minus 5/9 times 32. And 5 times 32 is 160. 9 times 1 is 9. Okay, so we still want to get f by itself. Here is our f term. So we have to do the inverse of subtracting 160 over 9, which is adding 160 over 9 to both sides, making our new equation c plus 160 over 9 equal to 5/9 f. And last step, we need to get f by itself. And right now it's multiplied by 5/9. When you divide fractions, it's the same as multiplying by the reciprocal. So we actually want to multiply both sides of this equation by 9/5. that is what is going to undo this fraction. But then we also want to multiply this side by 9/5. So we have our f by itself, but we should also use our distributive property to multiply 9/5 through. So 9/5 times c would be 9/5 c. And then 9/5 times 160 over 9. 9 over 9 cancels out. And 5 goes into 160 32 times. So we would have plus 32. So here's the equation when you're solving. In this case, this is actually Celsius to Fahrenheit conversion. So when you're trying to find the degree in Fahrenheit, this is the formula you will use.